Now, question number 2. The following data on the number of girls to the nearest 10 per thousand boys in different section of Indian society is given below. Section: scheduled caste, scheduled tribe, non-SC/ST, backward districts, non-backward districts, rural and urban. Scheduled caste therefore SC 940, number of girls per thousand boys 940, 970, 920, 950, 920, 930, 910. Represent the information above by a graph. And second question, in the classroom discuss what condition can be arrived at from the graph. Here, first we draw graphical. This data in graphical section we write on x-axis and number of girls per thousand boys here. But what is the measure? 940, 970, 920, 950. It is 900. Taking 100, 200, 10 marks in your graph, 200, 300, 400, 500, 6, 700, 800, 900 and here 1011. We write here number of girls per thousand boys, number of girls per thousand boys. And here we write section: scheduled caste, non-scheduled caste, scheduled tribe, non-SC/ST, backward district, non-backward district, rural and urban. Suppose I write here scheduled caste, here scheduled tribe, non-SC/ST, then backward districts, here we write backward districts, non-backward districts, non-backward districts, then we write rural and urban. Here rural and urban. First 940 SC 940, 900, then 1, 2, 3, 4, 910, 20, 30, 40. In 4 section we write here SC. 970 is here. Then write 920 non-SC/ST 920. All are above 900 to 1000. The values are between 900 to 1000. A 10,000, a 1,000. 920, 950. Backwards districts here 950. You draw 950, 920, then draw 930 and 910. 930 and 900. From this, what conclude we say that? We say that highest number of girls, maximum number of girls per 1000 boys in scheduled tribe, and minimum number of girls per 1000 boys in urban section. Then we write, from this we say that non-SC/ST and backward district sections are for number of girls per 1000 boys section in same section of non-SC/ST and non-district graph. Here it is like this and this. You write like this. But first we draw, how we draw this bar graph. We take here section on x-axis, otherwise we write here scheduled caste, scheduled tribe, non-scheduled SC and ST, backward scheduled. You don't write like this in this column, or draw this type, otherwise you take your design in this part. Plane is also. Now question number 2 is completed here. You draw in your graph book with proper scale and with pencil and scales. Now question number 3. Given below are the seats won by different political parties. If polling outcomes of a state assembly elections, political party A, B, C, D, E, F, and seats won 75, 55, 37, 29, 10, and 37. Question number 1. Draw a bar graph to represent the polling results. Which political party won the maximum number of seats? You see which political party won the seats maximum number? Party A. Here we draw and give this question answer by after drawing the graph. Here we write political party. It is A, B, C, D, E, F. We write here its value variable. No variable right here. A, B, C, D, E, and F. You write like this. But here no. Then 75, 55, 37, 29, 10 and 37. Which measure we take here? Minimum 10 and maximum 75. Then we take here 5, 5. If you have 20 blocks in your graph book, otherwise you take here 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. It is a seed swans. Seed swan. Now draw bar graph. Party A wants how many seeds? 75. Then party A 70 and 75. Party B 55. Party B here between 50 and 60. 37. Party C. Party C 37. Where is yes 30 and of 7 arcs in your graph book. You take 7 cards. Then 37. 29. Party D. Nearer to 9, 20 and 9 arcs. 29. 10. Party E wants 10, 6 and 37. Here 30 and of 7. We draw here question 1. It's question 1. Draw its graphical part. And second question. Which seed? Which party won maximum seed? This party. From this graph, we say that this party, which party? Party A, political party A won maximum seat. It is 75. Now, question number 3 is completed here. Now, good morning. Question number 4. Exercise 14.3. The length of 14 leaves of a plant are measured correct to 1 millimeter, and the obtained data is represented in the following table. Length in millimeter and number of leaves 118 to 126, 127 to 135, 136 to 144, 145 to 153, 154 to 162, 163 to 171 and 172 to 180. Number of leaves 3, 5, 9, 12, 5, 4, 2. Draw histogram. In here, draw histogram to represent the given data. First one, the class interval continuous. First we make class interval continuous. Second question, is there any other suitable graphical representation for the same data? Yes. For the same data, we draw histogram and polygon. Is it correct? To conclude that the maximum number of leaves are 153 millimeter long. Why? Question number 3. It is correct. Here, which class interval? The maximum number of leaves 145 to 153. Having 12 number of class leaves, but all leaves having no length 153 millimeter, having between, it is between 145 to 153. Now, first we draw a histogram and we take here modified frequency table. Modified distribution. We draw here frequency distribution. One, we draw first in histogram. It is compulsory continuous class leader, continuous frequency distribution. But here 118 to 126, 127, it is not continuous. First we make it continuous class, continuous distribution. Here length millimeter and number of leaves. How we make continuous class distribution? 118 to 126. Then we write its upper limit point and lower limit point. Here its lower limit point is 117.5 and 126.5. 126.5, 0.5 less and 0.5 greater for its upper limit. Here we write 127 to 135, 127, 0.5 less than 126.5 to 135.5. Then we write here 135.5 to 144.5. 144.5, it's 153.5. 153.5 to 162.5. 162.5 to 171.5 and 171.5 to 180.5. Here it becomes continuous class 117.5 to 126.5. Continuous, here see 126.5 to 135.5, 135.5 to 144.5, 144 point to 153.5, 153.5 to 162.5. We write here number of days 3, 5, 9, 12, 5, 4 and 2. It is our modified frequency continuous frequency distribution table. Now we do histogram. Here 117 to 180.5. We draw here king. In standard 9 we learn, suppose it is not continuous, then we draw king. Then we write here 108.5. 1 plus is from this 117.5, 126.5, 135.5. Here 144.5. 153.5, 162.5, 171.5, 180.5 and 189.5. So on. We take here one class preceding and succeeding class. Then here 3, 5, 9, 12, 5, 4, 2. We write here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here we write length of leaves. In millimeter, we write here number of leaves. We write here number of leaves. 117 to 126.5. Here 3. 117, 3. 117 to 126.5. From this interval, it is number of leaves 3. 126.5 to 135.5, it is 5. 126.5 to 135.5. Same width of this rectangle, 135 to 145.5, 9. 145, then 12. Suppose here 135.5. We write here 166.5, 171.5, and then 180.5, 189. Divide them 5. 153 to 162, 5. 3, 4, 5. 5 is here. In your graph, it is same measure. Your length, your width of rectangle are same. Here 162.5 in 171.4. And 171.5, 180 point, it is 2. Here all rectangles, it is shape of rectangle, their width are same here, and they are continuous. Histogram is drawn for continuous class distribution. Suppose it is not given, then we make first we modify it is in convert into class continuous class interval, and then draw histogram taking value. Here we take the limit of histogram, limit of class interval. Now question 1 is what? Question 2. Did you draw any graph? Yes, we draw frequency polygon, its mid value. First we find its mid value. Mid value is 177 plus 126 divided by 2. 244, 122.5, 122. Here it is taking here like this 122. It's one middle point, and we draw its histogram, its frequency polygon. Join this point by scale. Then using scale, this point join. This point and this point. We draw histogram. Find its and join it is by this class. Otherwise you don't join. And question number 3. Which have number of leaves have maximum number of leaves have length 153 centimeter? No. Because it is lying between 145 to 153 class interval, there is no, all leaves have no, 12 leaves have no length 153 millimeter. It have 145 to 153, therefore 145, 146, 148. Between this, then your question number 4 is completed in your here you completed in your graph book. Now, question number 5. gives lifetimes of 400 neon lamps. Here, lifetime in hours and number of neon lamps. Lifetime 300 to 400, 400 to 500, 500 to 600, 600 to 700, 700 to 800, 800 to 900 and 900 to 1000. Number of lamps 40, 56, 60, 86, 74, 62 and 48. Question number 1. Represent the given information with the help of a histogram. And how many lamps have a lifetime of more than 700 hours? How many lamps have a lifetime of more than 700 lamps? In this question, it is a continuous frequency distribution, continuous class interval frequency distribution. Yes, 300 to 400, 400 to 500, 500 to 600. It is a continuous. Here 400 included in this class, 500 included in this class. Then we do not modify this class interval. Here we have given it is continuous frequency distribution. Then we draw graph. You take here 300, 400, 500, 1000. Suppose you take here from 300, otherwise you take like this 100 and you take pink here. And we write it is 200, we write 300, 400, 500, 600, 700, 800, 900 and 1000, 1100. It is our lifetime in or why we draw? Because here 0, then it is not continuous difference between 100. Here it is 100, but 0 to here 300. Then our difference is 300. Therefore, we write it is ink. Then it is completely different. Now 40, 56, 60, 86, 74, 62, 48. We take here 10, 20, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. It is number of lamps. We write here. Now we draw histogram. 300 to 400, 40. 10, 11, 12, 13, 14. Here 4 blocks. And take 300 to 400. 400 to 556. You draw yourself in your notebook. 56, 50, 55 and 56. And tally with my graph. Like this. Not measure or equal. 60. 86. 80, 85 and 86, 74, 70, 1, 2, 3, 4, 62 and 40, 62 and We draw here histogram. Then question number 2. How many lamps have more than 700 lifetime or lifetime? How many lamps have 700 more than 700 hours more than lifetime is 700 more than. Then how many lamps? 74 more than 70. 700 is here. 74 plus 62 plus 48 equals to 184 lamps have lifetime more than 700 hours lifetime. Question 2 is how many lamps have a lifetime of more than 700 hours? 184 lamps have a lifetime of more than 700 hours, have a lifetime of more than 700 hours. 700 hours. Here question number 5 completed.